here to introduce Desert Aquaponics, a project put together by myself and Yoram Etrog. I, Adrian Barnes, am a fish farmer for 35 years and Yoram is a vegetable grower for 35 years. In the past 20 years, aquaponics has become from an internet dream into reality, though if one does a search on the internet or through communication with companies dealing in aquaponics, it's still very rudimentary. Claims are that aquaponics can save 95% of the water, doesn't require any contact with soil for either production of the fish or the vegetables, and that it is capable of being in any place independent of the environmental conditions. So with all of this hype going on, we have decided to test claims that are being made in a practical way. And Desert Aquaponics, the company, was formed in order to do this, and thereafter to use the technology and knowledge that came from this process to create modules that can be placed anywhere in the world for the production of vegetables and fish. What are we doing in this experiment? Simply, we are growing fish in tanks, supplying the vegetables with the water from the fish production and recycling this through filters to the fish once again. We're recording all of the inputs and all of the outputs from this system, and we're going to compare the economics with the existing production of fish in intensive systems and the existing production of vegetables that goes on around the world and in Israel is at very high technology levels. This is the fish part of the aquaponic system. It consists of 4 tanks, each with about 1 cubic meter of water. The tanks are fed by these pipes that come from a degassing filter and from a denitrifying filter, which is used to transfer the ammonia of the fish into nitrite and then nitrate that the plants can absorb. Each fish tank has a sump at the bottom below the aeration system that collects the fish feces at the bottom of the tanks, and this is emptied on a daily basis to this sump, and the concentrated feces are washed out to the plants in the soil garden. Water coming out from the tanks goes into these pipes through a vortex filter that settles any remaining large solids, and through a brush filtration tank with 4 compartments that again removes the remaining small solid waste before it goes through the pipe into the canals of the vegetable system. Outlet from the canals of the vegetable system into a sump where there is a series of 2 pumps, 1 reserve, and a float that adds water to the system to replace the removed water from the flushing and from the transpiration of the plants. This is the vegetable growing part of the aquaponic system. Consists of canals, floating styrofoam sheets with the plants planted in the styrofoam in cups from the seeding trays. What you see here is the plant system a few days after a sandstorm that we had in the desert, and you can see that there's quite a lot of dust on the leaves. The system here consists of 2 types of plants, a body of plants that is many different types, includes baby leaves, beans of various types, courgettes, lettuces, leeks, and various herbs, basil, coriander, parsley, and half of the system composes a set of cucumbers and tomatoes that are used as a comparison to the agricultural farmers using normal greenhouse systems in the desert. The climate is a lot hotter. Here it is cold at night and hot during the day. We, however, seem to be getting reasonable results, and the aim of the experiment is to see whether the yields are comparable in this system to a normally irrigated system. We seem to be using about 10% of the water that is normally used for irrigating the same amount of plants, and the water is measured, and we will know at the end of it our water usage. The fish production is also being monitored, and the weight of fish produced over the period will be compared to intensive systems that grow fish without a plant filtration system attached to them. The amount of roots in the canals increases the filtration area of the biological filters, and the plants absorb the nitrates, thus releasing the system from its nitrogen load.